Good day. In this video, we're going to talk about the application of derivatives, and that is derivative as a rate of change. The derivative of a function f given by y equals f of x with respect to x at any x in its domain is given by dy over dx equals the limit of delta y over delta x as delta x approaches to 0 equals limit of f quantity of x plus delta x minus f of x over delta x as delta x approaches to 0, provided that the limit exists is the same as the rate of change of the function y equals f of x with respect to the independent variable x. So it simply means that derivative tells us how a function changes with respect to the independent variable. That's it. Okay, let's try to answer this item. On number 1, find the rate of change of y with respect to x. Y equals x squared minus 3x when x equals 6. So again, rate of change and derivative tells us how a function changes. So this item, number 1, asking us to find the derivative of the given function and then substitute the value, a given value for x, which is 6. Okay. And to do that, we need to use the power rule. So y equals x squared minus 3x, the derivative of that will be equal to 2x minus 3. And then substitute the value 6. Therefore, the rate of change, it's going to be 2 times 6 minus 3, and that is 9. So the answer is 9. Next, number 2. Y equals 5 over 2 plus x squared. And so this is the rule that we're going to use, the quotient rule. The low, the high minus high, the low over low squared. So using that, the function 5 over 2 plus x squared, the derivative of that, by following the pattern of the quotient rule, will be 2 plus x squared, the denominator, times 0, the derivative of the numerator, minus 5, the numerator, and then times the derivative of the denominator over the denominator squared. And that will give us negative 10x over the quantity of 2 plus x squared, quantity squared. Next, worded problem number 1. The dimension of a box are x, x minus 1, and x plus 1 centimeter. Find the rate of change of its total surface area, total volume as x increases. Give units of the answer. And this is the illustration. So the given dimension are x, x minus 1, x plus 4. And to solve it, first for the total surface area, the surface area is equal to 2 length times width plus 2 length times height plus 2 width times height. And these are the given dimension. So just follow the formula and it will give us this 2x times x minus 1 plus 2x times x plus 4 plus 2x minus 1 times x plus 4. Okay, and multiplying that, it will give us 2x squared plus 2x squared minus 2x plus 8x plus 2x squared plus 6x minus 8. And that is equal to 6x squared minus 12x minus 8. Now this is the area of this box, but we need to find the derivative of it. So the derivative will be 12x minus 6 using the power rule, and the unit will be centimeter. So 12 times x minus 1 centimeter squared over centimeter. X. For the volume, So the volume of a rectangular prism is length times width times height, and these are the given dimensions. So just multiply the three of them. Volume is equal to x times the quantity of x minus 1 times x plus 4. So that's going to be, multiplying them, give us x times x squared plus 3x minus 4. And that is x squared plus 3x squared minus 4x. And then finding the derivative of that, it's going to be 3x squared plus 6x minus 4 cubic centimeter over centimeter. Next, worded problem part 2. Number 2 item, find how fast the surface area, volume, and diagonal of this given cube. Okay, so the edges are letter E, the diagonal of the box is D, and then the diagonal of the edges is X. Okay, find the surface area. The formula for surface area is this. Surface area equals 6a squared, where in a is equal to the edges, or representing the edges. So just by following it, we will get 6e squared, and then get the derivative of that, that be 12e. That's it. Next, finding the volume. The volume of a cube is S cubed, wherein S is representing the edges, and in our case, we use E to represent the edges. So just change the letter. Volume is E times E, or E cubed, and the derivative of that is 3e squared. Derivative of the volume is 3e squared. Next, the diagonal. Now, okay, so for diagonal, we do not have a formula for that, but we can use the Pythagorean theorem, because as you can see, the D here together with the diagonal X and the edges here make a right triangle, where D is the hypotenuse. So we can follow the formula of the Pythagorean theorem, and that will give us c squared equals a squared plus b squared. That's going to be d squared equals x squared plus e squared. Now this x squared here, that is the x here, also form a right triangle together with the edges. It's e. Okay. So again, we can use the Pythagorean theorem to represent x in terms of e. So that would be x equals to square root of e times square root of 2 times e. So we can write that as d squared equals the quantity of square root of 2 times e squared plus e squared. And that is d squared equals 2e squared plus e squared. Adding them together, that will be d squared equals 3e squared. Getting the square root of both sides will give us d equals square root of 3 times e. And then look for the derivative. Find the derivative. And the derivative will be square root of 3. That's it. That's how fast the diagonal is. Okay, so that's all for this video. That is the basic application of derivative as a rate of change. Okay, thank you for watching. Goodbye.